Okay, so we had a notoriously diabolical maths paper for advanced, and Charlie had some advice on how you could prepare for it.
Yeah, so I mean, to like the fellow advanced students, the problem is it's really not a matter of intelligence or like hard work. Like I'm sure if anyone did the accelerated paper this year, or you would know it's like markedly difficult. And I think that upon some sort of considered analysis, what I realized is it's actually really similar to the extension 1 or extension 2 sort of like style. And what sort of defines that style is like abstract puzzles. And the unfortunate thing is, puzzles aren't a great metric for sort of evaluating a student. But nevertheless, right, we have to, that's what the markers ask for. And so I guess my advice to you guys would be, try to, once you learn those techniques that I guess become by the end of the course, like rudimentary, like, quadratic formula and geometry and that sort of things, start trying to do harder, I guess, problem solving. So solving puzzles, and I guess sort of trying to sharpen your mind a bit, because it's very easy to just get lulled into this sort of idea where all I'm going to be doing is presenting the marker with like what I know, and unfortunately that's not the case, even though that would be probably a better metric to assessing a student. What they want is demonstration of like abstract thinking ability, and that's hard under exam conditions. But I mean, to be fair, if you can write like a creative piece of writing under, that you just sort of come up with in the blue, an original solution to a maths problem is fine. That's that you can do that. But the key is to spend time practicing this skill, and it's one that needs refining, because obviously approaching a problem, there are an infinite number of ways to do it, right? But by learning how and what makes a problem, I guess, tick, and the nature of different problems, you learn to very quickly become efficient at knowing what paths work and what paths don't. So anyway, my advice is, if you do come across a problem that's really hard, take time in like deliberate time, like considered study in learning why that problem was difficult and what was the particular trick they used. Like, just as a quick example, I know that a lot of problems tend to orbit around the discriminant. And even though you think the discriminant is this little quirk of like the quadratic formula, it turns up as a really useful problem solving technique. And anyway, your job is to find out why. Why is the discriminant important? Anyway, that's my advice. But I think it's important. It's genuinely important that you know that. So yeah.
Amazing. Yeah. Thank you.
That is